So in physics, we're going to be studying motion a lot, and we need to be able to describe the location of an object when we measure it. And we need to use coordinate systems to do that. I'm sure you've used coordinate systems before, but I just want to review a few things with you. A coordinate system requires that you specify an origin. It requires that you have axes with some sort of scale to indicate your unit for measuring distance. And we need to have some instructions for how to label points in this coordinate system. So here are several types of coordinate systems that we'll be using in this class. There's a 1D, one-dimensional. That just looks like a line. You got your origin here, and you have some sort of scale with markings to indicate distance from that origin. Maybe this is your position X in meters. Maybe 1 meter, 2 meters, 3, -1, -2, -3, and so on. And you can specify a point in that coordinate system, maybe like 2.6 meters to the right of the origin. A 2D coordinate system might look like a Cartesian coordinate system with X and Y axes. So again, there's our origin, and we have two axes. Maybe we use meters again. And maybe we've got a point here. That's 2 along X and 4 along Y. That's how we specify the location of that point. But another type of coordinate system that you might use instead is polar. So rather than X and Y coordinates, we indicate a distance from the origin and an angle with respect to a reference line. So a polar coordinate system could look something like this. Here's our point. Here's our reference line. Here's the origin. And this point is some distance r from the origin and some angle theta. So maybe it's like 5 meters and it's 43 degrees above that reference line. Now in physics 6, this is pretty much all we're going to encounter, but there are other types of coordinate systems that that you end up using a lot, especially as you go farther in physics. There's 3D coordinate systems. Where you need an X, a Y, and a Z coordinate, or 3D spherical, or 3D cylindrical. And there are even other types of coordinate systems that are used in crazier situations, like in general relativity, but you won't need those.